All right, so good morning. This question is a bit medium complexity level question. Let's read the question. It says that there is a body which is having angular momentum of this magnitude, and the body is moving in the line along the line which is given by this equation. Okay? You have to find what is the magnitude of the force acting on this body. Now, if I look into the question nature, right? So the first thing I notice is that it's a time varying angular momentum, right? Time varying angular momentum. So which means the angular momentum is varying. So my conclusion from here is the central idea is that the body is being acted by some torque. That is very, very clear in my mind. If I have angular momentum which is varying, I'm being subjected to a torque, okay, which is analogous to the translatory motion where you see change in linear momentum, and the conclusion is that I'm being acted upon by an external force. All right. Second is the position of the body is given, the direction in which it moves. So let me just reduce the size of this question. I hope you've read it carefully and now we can solve it. Okay. So the body is being subjected to torque. Question is, what is the force being acted on the body? Okay. If I just put the two words, the torque and the force, I put them side by side, what comes to my mind is that torque is equal to, okay, force into R into sine theta. Okay? This is what comes in my mind. Okay, and so force is available, torque is happening. Okay, we will tackle R in sine theta. We know it's a perpendicular distance from the axis of rotation to the line of action of the force. So whatever is the direction of the force, you draw a perpendicular from the axis of rotation. And obviously this question deals with a point mass. So this is an angular momentum of a point mass. So we're dealing with mvr. We did this in the previous numerical. Okay, go back to the angular momentum numerical. I have done an hour ago, okay, on the playlist. So this is available, right? How do I find torque, right? So the torque is given by, in this scenario, will be given by what? dl by dt. So is equal to 3, right? Because I've taken the derivative of this. So more calculus oriented question, right? So this is more calculus based kind of question. So I know the value of the torque, Newton meter, right? So this is my torque. Let me put it here, right? 3 is equal to F R sine theta. Now I know, at least I've been able to get a torque. What I need is the perpendicular distance between the axis of rotation and the line of action of the force. If you don't understand this, go to my playlist and understand how to calculate torque. The line of action of force, it's a direction of the force with a perpendicular distance to the axis of rotation. If you read this question carefully, whatever is being calculated is around the origin, right? I told you angular momentum is not an intrinsic property. It depends on choice of origin. All right. So let's do a small diagram to get hold on what is happening. So I know this is y is equal to x minus 2. The diagram. So I'm going to put x is equal to 0, y is equal to, and x is equal to 2, y is equal to 0. So the line looks like this. And this is the equation, y is equal to x minus 2. This is my 45-degree angle because the slope is y is equal to mx plus c, right? So y is equal to mx plus c, and my slope here is 1. Okay, 1, y is equal to x minus 2, and therefore this is the slope. Tan theta is equal to 1 and theta is equal to 45 degrees. Okay, at least I have some angle with me now when I look into r sin theta. What is my axis of rotation? My axis of rotation is this. Let me calculate the perpendicular distance. Okay, if you calculate, if you're given a point and you have to calculate the perpendicular distance, how do you do that? Right? So what you do is, this is also 45 degree, this also is 45 degree, right? And what are the coordinates of this point? We say the coordinates of this point are 2 comma 0, and the coordinates of this point are 0 comma minus 2. Okay, this is the scenario, and we know this angle is 45 degrees. So if I know this is 45 degree and the length of this particular okay, say this is 90, right? So this is your hypotenuse, and one of the hypotenuse is given to be 2, right? Hypotenuse is given to be 2, and the perpendicular has to be found out. So perpendicular upon hypotenuse is equal to, this is the perpendicular, R, the perpendicular on the line of action of the force. So this is the way I'm saying, the line of action of the force is this is the perpendicular which is coming. Okay, so this is the line of action of the force. This is the perpendicular. So this will come out to be, perpendicular is equal to sine of 45 degree, right? So we have concentrated on this small triangle. Look at this triangle, this one. Okay, this triangle is the area of interest for us, right? So perpendicular is equal to 2 into 1 by root 2. All right, so this becomes P is equal to 1 by root 2 into 2 is equal to root 2. Let's substitute here. So this is root 2, and therefore F is equal to 3 by the root 2 newtons. So you can see one of the choices is 3 by root 2, and that is the correct choice. So I hope you like this video. Please don't forget to subscribe to this channel for the simple reason it caters to the needs of all board examinations. Whether you're appearing for IB board, you're appearing for AP Physics, you're appearing for Cambridge, Edexcel, you're appearing for NEET and JEE mains in India, or any other exam in India, or for that matter, any part of the globe. The underlying physics does not change, right?